Hello friends, meet my friend Ayesha. Let me tell you, she is very intelligent.
Rahul, you are intelligent too, but you prefer someone to speak highly of you. Anyways, this time I scored more marks than you in physics.
Yes, that's why you are here today.
What is the name of the topic which we will be discussing today?
Today's topic name is Refraction.
Till now, what have you learned, Rahul?
We have already learnt about light, reflection, and how the rays of light get reflected by different objects. But Ayesha, there are some questions in my mind.
Like?
What will happen if those objects are not opaque but transparent? Will the light still be reflected? Will the rules of reflection still apply? Will the rays still follow a straight line path?
In today's video, we'll discuss these questions and learn about a new phenomenon known as refraction. We'll do a very interesting activity to explain refraction, which we can do at our houses too. To perform this activity, we need a bowl, a coin and water. I put this bowl on the table and put the coin inside the bowl. Rahul, can you see the coin?
Yes.
Very good. Now slowly move backwards from the table until the coin is not visible. Can you still see the coin?
No.
Now I am going to put water in the bowl without moving the coin from its position. Rahul, can you see any difference?
Yes, I'm able to see the coin. But how is it possible, Ayesha?
It is possible due to a phenomenon known as refraction. Firstly, the rays of light while entering your eyes were reflected by the coin. But when I filled this bowl with water, the rays entered your eyes were refracted and not reflected, due to which you could see the coin.
So did light change its path after refraction?
You get it right, Rahul. But to understand this concept in depth, we have to use this rectangular glass slab. To understand refraction of light through a rectangular glass slab, we need a glass slab, a white sheet, and 4 oil pins. After placing the slab on paper, we make an outline which will help us further. Fix 2 oil pins vertically such that the line joining the pins is inclined to the edge. Try to see the images of both these pins from the other side. Fix the other 2 pins such that these 2 pins and the images of the first 2 lie on the same line. Remove the slab and the pins from the paper. Draw a line marking the first 2 pins with the pencil, which will intersect the slab at O. Do the same procedure on the other side and give this point the name O'. Draw 2 perpendiculars at O and O'. Name the angle formed between the lines and the perpendiculars as angle of incidence and angle of emergence. Here the angle of refraction will be formed instead of the angle of reflection. Produce a straight line from the marks of the first 2 pins. Then join O and O'. A deflection can be seen between both the lines. Or it can be said that the ray of light changed its path while passing through the glass slab. This phenomenon of changing the path of light when passed through different transparent media is known as refraction of light. The incident ray, the refracted ray, and a normal to the interface of 2 transparent media at the point of incidence all lie in the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for a given pair of media. This law is known as Snell's law of refraction. The constant we get from the ratio is called refractive index. The extent of the change in direction that takes place in a given pair of media is expressed in terms of refractive index. In addition to it, the refractive index can also be represented by the relative speeds of light in different media. If the light is traveling from medium 1 to medium 2 and the speed of light in the first medium be v1 and in the second be V2. Then the refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 and the speed of light in medium 2. This is usually denoted by n21. Like this, the refractive index of medium 1 with respect to medium 2 is denoted by n12. If medium 1 is air or vacuum, then the refractive index is called absolute refractive index. Absolute refractive index is simply known as refractive index only. Vacuum and air are considered as rarer mediums. Some of the other materials are considered as denser mediums. You can check the refractive index of several material media with respect to air.
Wow, Aisha, you have explained this topic very nicely. I didn't know that you are a great teacher too.
You get it right, Rahul. I want to be a teacher.
All right, best of luck.
Thank you.
We shall meet you folks in our next video. Till then,
Bye-bye.
bye bye.